Okay, problem number 24, it says a sports car can accelerate from 0 to 60 miles per hour in 3.9 seconds. What is the magnitude of the acceleration? So again, for problem number 24, what we have here is we have a problem where we go, what's the initial velocity? So I've got 0 miles per 1 hour. That is the initial velocity. And then my final velocity is 60 miles per hour. And then my total time, and I'm going to write this a little different. I'm just going to call it delta t. So I'm going to say delta t is how many seconds? 3.9 seconds. Okay? And so what they want us to do is find the average acceleration. So what did you notice Mr. Adams did first? I wrote down all my information. I have an initial velocity, I have a final velocity, and I have a difference of time. So, and what do they want? The average acceleration. So to be consistent with your textbook, if we go back to page 59, or 57, on page 57, it says that the average acceleration is v naught minus v all over delta t. That's one way to look at it. What does delta mean? Change. Change in time. So if I do that this way, then I've got 60 minus 0, and that is miles per 1 hour. All over 3.9 seconds. So I've got 1 hour and seconds, and those are going to be multiplied by each other. So in the next step, what do I have? I have 60 over 3.9 second hours over miles. So if I plug that in the calculator, if I take 60 and I divide that by 3.9, I'm going to get 15.38, right? So this answer is 15.8 miles over 1 second hours. Well, acceleration is what though? What's the unit or dimensions of acceleration? Meters per second squared. So I need to take 15 miles second hours, and I need to end up over here with meters per second squared somehow, right? So in the front page of your book, what is the conversion ratio between 1 mile and meters? Isn't it 1609? Isn't it 1,600 and what? Tell me what it is off the top of your head, or look in your book. Well, we want miles to kilometers. So here, let me show you where to look. See in your textbook, see this right here? Let me zoom in on it for you guys so you can see it. See this right here? It's 1 mile is equal to 1,609 meters. Do you guys see that? 1 mile equals 1609. So I'm going to put 1 mile here to 1,609 meters. Now, what's the other thing? I got to deal with hours, right? So I'm going to say 1 hour is equal to how many seconds was it? 3,600. So the miles cancel with miles. Hours cancel with hours, and I get seconds squared on the bottom. So I'm going to do this on my calculator all in one step. You guys ready?
Yeah.
I appreciate your enthusiasm. All right, here we go. It's going to be on top here. If I say 15 times 1609, do I have to say times 1? No. All right. So then I'm going to divide this by just 3,600, it looks like, right? That's the only number I have on the bottom. Well, bam, with the bacon sizzle, I've got 16.7 or 6.70 meters per second squared. What's the answer in the back of the book?
There isn't one.
Oh, I have the answer right here. What's the answer in Mr. Adams' fancy teacher book? Well, they said 6.9, so that's because they rounded. That's because they rounded. What they did is they converted at the beginning and rounded to significant figures. Our answer is a little more precise. Any questions on that? The reason why the back of Mr. Adams' textbook is different is they converted in the beginning and then they rounded to significant figures. And Mr. Adams just did all the work and then rounded at the end.